This is the story of climate change. It is a story with one central character, the gas carbon dioxide. Once upon a time, no one used the term climate change. That began to change in the 1950s when some Earth scientists believed that the amount of CO2 in the atmosphere was increasing and wondered what effects this might have. When a paper suggested that human beings are carrying out a large-scale geophysical experiment that could not have occurred in the past, many more scientists took notice. A station was built in Hawaii at a site where measurements would be representative of the world's atmosphere. After several years, it confirmed that levels were rising. Almost everyone believed that CO2 levels would rise well into the future. A committee of scientists studied the matter and released a report. Although it stressed the uncertainty involved, it nonetheless concluded that the atmosphere is changing, that we ourselves contribute to that change, and that increasing CO2 will lead to a warmer Earth. Another committee was convened to take a second look. It examined the latest studies. Although its report described the difficulties in simulating the atmosphere, the conclusions were more pointed. The climate would change significantly within our lifetimes. The change will be large and rapid, and the resulting global warming would have socioeconomic consequences. Simulations at the time relied on a basic theory. It was described in simple terms to make it understandable to the public. More CO2 would increase warming of the atmosphere due to the well-known phenomenon of the greenhouse effect. Concerned by these reports, two UN agencies established the Intergovernmental Panel on Climate Change, the IPCC, and member countries provided substantial funding for research. The IPCC's first report stated that global temperature had increased 0.3 to 0.6 degrees in the last 100 years, and that future use of fossil fuels would cause global temperature to rise at a per-decade rate of 0.2 to 0.5 degrees. As research continued, two more assessment reports were released. Both said that improved research continued to confirm the findings of the first report. In 2000, the IPCC went further and cited additional research that addressed specific planetary effects of global warming and the details of socioeconomic consequences. The theory was modified to identify climate change as the outgrowth of global warming and many of the socioeconomic consequences as potentially severe. The term climate change became commonplace. With increased funding and wider participation, the IPCC continued to publish assessment reports. The later reports specified the future global temperature increases and their specific effects across various socioeconomic categories. They also suggested that there was a risk of irreversible and abrupt changes from greater global warming. Across the 30 years of IPCC research, ways of measuring global temperatures had expanded. By the sixth report, the IPCC declared that global temperature had increased by around 1 degree since 1900. The first report had predicted that global temperature would rise by 0.2 to 0.5 degrees per decade. The latest report stressed that with improved measurements, historical trends were an appropriate gauge for future temperatures. Decades ago, scientists suggested that a large-scale geophysical experiment was underway. Today, the preliminary results of the experiment are in. One measured quantitative result is that greater levels of CO2 have enhanced plant growth. Crop yields have increased significantly, primarily due to more CO2 and aided by lengthening growing seasons. Trees and grasses are growing faster, are more drought tolerant, and are spreading to once barren areas. But what are the measured results of global temperature? How has your climate changed in the recent past? From official temperature records going back well over 100 years, here's the change in average annual temperature in various locations. Two things stand out in contrast to the IPCC global surface temperature. There is great regional variability in temperature increases, and some regions exceed the global average, while others are much less. The record for Perth, Australia points to another aspect, that daily maximum temperatures have changed differently than daily minimum temperatures. A case in point is Central England. A rural station has been recording temperatures since 1650. Red is for summer, blue is for winter, and green is the averaged annual temperature. As shown, in the 100 years from 1920 to 2020, the temperature has risen 1.2 degrees. Meanwhile, the summer temperature rose the same 1.2 degrees, while the winter temperature less at 0.7 degrees. And for the temperature record as a whole, the temperature rose 1.5 degrees since 1650, which equates to 0.4 degrees per century. As Yogi Berra famously said, it's tough to make predictions. Is there a reason that early predictions overestimated the temperature increase? A trailer after this video suggests a possible explanation. Today, the story of climate change continues from where it began, with the story of carbon dioxide. The increase in carbon dioxide has enhanced plant growth, and it has been accompanied by manageable, beneficial warming. Calling on Yogi's unique wisdom, the future today isn't what it was decades ago. The early model predictions of global warming overestimated the temperature increase for the coming decades. This short video suggests a possible reason. The basic theory of early climate models was that greater CO2 increased the greenhouse effect, causing the atmosphere to get warmer, which would result in consequences. In actuality, the early theory included a significant positive feedback mechanism. It posited that more CO2 would warm the atmosphere through the greenhouse effect, and that this would cause more water vapor, also a greenhouse gas, to enter the atmosphere, boosting the greenhouse effect, which would increase the amount of warming. Over the years, new models were created to explore the consequences that resulted from increased global warming. Yet the atmosphere models remain locked into a positive feedback scheme. So overestimates of warming flowed into all other models, making the consequences more severe. There was one other problem with atmosphere models. They were unrealistic. The models generated an output that didn't physically exist: global surface temperature. When models were programmed into computers, their numerical output was an artifact. It was a number that could not be correlated with the historical record, which was based on air temperature. This made the models unverifiable. There is no record of global surface temperature from the 1850s, and there is no measurement of global surface temperature today. The nearest approximation is to combine ocean surface temperatures with land air temperatures, which is problematic. So the matter of how CO2 is contributing to global warming remains unresolved. The latest IPCC report concludes that, as part of global surface temperature, worldwide land temperature has increased 1.6 degrees Celsius since before 1900. This is in contrast to per-century air temperature increases in different regions. Interestingly, taking the average of the arbitrarily selected regions shows agreement with the IPCC value. But when Washington, D.C. and Tokyo are dropped out, the average drops well below the IPCC value. Models have evolved to adopt today's theoretical framework. It starts with all man-made greenhouse gases. Each of these has a different GWP, or global warming potential. They contribute to radiative forcing, which, through interactions and feedback mechanisms, results in an effective radiative forcing, which causes global warming. The warming manifests itself in climate change, which is evidenced by changes and modifications to regional climates. These in turn generate changes in things such as shifts in weather patterns, changes in glaciers and sea ice, and possibly new patterns of hurricane activity. And depending on the ECS, the equilibrium climate sensitivity, the models can predict the degree to which things change. The latest IPCC assessment report revealed that the newest models were now, for the first time, constrained by the warming that has been observed in the past. This is essentially a tacit admission that previous models were based on theories and guesses, which may also explain why their predictions didn't hold up. Yet the models still hinge on a guess: the equilibrium climate sensitivity. This is the change that models respond to when the level of carbon dioxide is doubled. The latest report assigns the ECS a range of 2 to 5. And for good measure, the writers of the report said an ECS of 3 was most likely. It was the best guess. Perhaps in another 40 years, we shall see how the newest models fared. If we could ask Yogi Berra to summarize IPCC models, it might go like this: the models weren't wrong, they just weren't right. But remember, the IPCC remains under the control of politicians. The conclusions in the reports are written and approved by politicians. For as one witness made clear during Senate committee hearings 4 decades ago, the environment is too important to leave to the scientists.